TimeElide, visual analysis of non-contiguous time series slices. Time series data is typically a contiguous range between start and end time. Visualization tools support the analysis of this data type through open-ended exploration. Or the data is aggregated and visualized as contiguous intervals. We consider a different problem scenario and introduce the data abstraction of non-contiguous time series slices. We distinguish between two main types. First, the data is recorded continuously, but the user wants to analyze specific known time slices of interest, such as Mondays 9 to 5, weekends, or public holidays. In the second case, the data is naturally divided into slices and not continuously recorded, such as workouts, bike rides, or soccer games. Non-contiguous time series slices can have regular or irregular intervals. They can have a fixed or variable length, and each slice can have a fixed or variable number of data points. We propose a visual encoding design space for these non-contiguous time series slices and analyze 8 different visualization types. Further details about the design dimensions are described in our paper. We instantiate this design space in TimeElide, an open-source domain-agnostic tool for the visual analysis of non-contiguous time series slices. And we demonstrate the utility of TimeElide in 4 usage scenarios based on real-world data. The first scenario is about the activity during soccer games. The number of actions of a single soccer player are recorded every 5 minutes, and a player wants to analyze how their activity changed during individual matches and throughout the season. They upload a CSV file with all the data and assign the column names. The player selects the option to automatically detect existing slices. TimeElide identifies 22 soccer games of 90 minutes each and shows a Sparkbox visualization. The user hovers over the Sparkboxes to see more details in a pop-up window. And they notice that they were substituted in during 6 matches. The number of actions is 0 for most of the time and increases only at the end. On the global timeline, below the Sparkboxes, they can see that they did not play at all in September. The player changes the visualization type to 2D heat map to analyze if there are any differences between afternoon and evening games. The slices are again juxtaposed along the x-axis. The y-scale is set to absolute time and shows the range between the earliest match start time and latest end time. The user changes the number of bins to 30 to see more details. And the soccer player learns that their coach typically substituted them in during afternoon matches. The second scenario uses building occupancy data that is recorded every 5 minutes. An analyst wants to understand the weekend use of a building to improve the scheduling of custodians. They upload their data set into TimeElide and choose to manually specify slices. They select Saturdays and Sundays and visualize the results as Sparkboxes. The analyst removes all slices without any available data and zooms in to see more details. In general, the occupancy rate is relatively low, which is expected for this building. They notice a few Saturdays with significant activity, but no repeating patterns. The analyst wants to better understand how the occupancy typically changes throughout the day. They select the visualization type multi-series line chart, which shows all time slices superimposed. They notice some data quality issues during 2 days, but they also learn that weekend activity rapidly decreases after 4 or 5 p.m., and no evening events take place. The next scenario focuses on bike rides and uses data from a tracking device that records the median speed every 5 minutes. A hobby athletes want to analyze all bike rides in one place and see how the performance changed. The user automatically detects existing slices and selects the 2D heat map. They also change the Y-scale mode to absolute duration and increase the number of bins. The user can see that most of the rides have been around 1 hour long, and there have been 2 longer day trips. They change the visualization type to Sparkboxes, remove the raw data, normalize the slice widths, and show the average speed during each bike ride instead of the median. The result is a visualization with boxplot bars summarizing each bike ride. There seems to be more variation in average speed in the latter months. In the last scenario, a manager wants to analyze when the bakery is most busy. They use the number of sales transactions that are logged over several months and aggregated into 15-minute bins. They upload the CSV file to TimeElide and change the title of the variable of interest to Number of Items Sold. They choose the option to automatically detect existing slices. The manager selects the stepped area chart to analyze the number of transactions on different weekdays. They quickly spot a weekly pattern with more sales taking place between Friday and Sunday. The manager changes the slicing method and manually specifies only Fridays, Saturdays, and Sundays. They visualize the data using the 2D heat map and increase the number of bins. They can see that there are often spikes in sales between 10 a.m. and 2 p.m. and decide to hire additional staff for these periods.